Alrighty, so today we're going to be having a look at solving for angles. Now, before we go to this, there's just one little side note I want to go through. And it's a simple question. Would you rather have $1, root 2 on $2, or root 3 on $2? Or even $0.50? Which would you rather have? Now, some of you might immediately spot what's going on here. But before we do, let's ignore the 1. We can deal with 1 in a moment. Let's just look at these 3, and then I'll ask you the question. Which would you rather have? $1, $2, or $3? Well, hopefully most of you would agree that you'd rather have $3 than $1. Next question is, would you rather have root $1, root $2, or root $3? I'll let you have a look at your calculators if you want, but if you think about it, root $1 is just 1, root 2 is going to be a little bit bigger than 1, and root 3 is going to be a little bit bigger than root 2. So you'd think this one would be the biggest. Then all we have to do is halve each of these. Would you rather have $1, root $2, or root $3? Would you rather have $0.50, root 2 on $2, or root 3 on $2? I might go, why is this relevant? Well, I'm just going to change this middle value here to look like how we normally see it, which is 1 on root 2. And now this becomes a really useful strategy for solving these functions. Okay? Now, let's go through and having a look at. Let's imagine we've got cos of theta, and we're solving it for root 3 on 2. When is cos of theta equal to root 3 on 2? Well, draw in our unit circle, and let's go x-axis, y-axis. We're interested in cos. That's the x-axis, and we're looking for root 3 on 2. So, let's think about where we'd put these. Well, a half's about there. Well, 1 on root 2 would have to be a little bit further along, and root 3 on 2 would have to be even further along. So let's draw an angle about here. Now you see that there's a few solutions here, right? There's one above the x-axis and one below the x-axis. This angle here, and this blue angle here as well. So these are our two solutions that we have. Now, in practice, if we just want the basic solution, well, we're usually interested between the angles of 0 and 2 pi. So we're usually interested in the two basic solutions for these. Now, most of them have two solutions. Some of them will have one solution as well. So now I've just got to work out what these angles are. Well, these both appear, this angle here, this value, root 3 on 2, only appears in one of our triangles, and it's the pi on 3, pi on 6 triangle. So let's break it down into sixths. So that's 3/6, 4/6, 5/6, 6/6, 7/6, 9/6, 10/6, 11/6. Alrighty? So, the first angle that we have is just going to be pi on 6. And the second angle, this blue angle out here, is going to be 11 pi on 6. And those are the two solutions if we're looking for non-general solutions. So theta 1 is equal to pi on 6. Theta 2 is equal to 11 pi on 6. I'm going to go through one more example and we'll see how that goes. Alrighty, let's have a look at tan of theta is, we won't do tan just yet. Let's do a sine first. We'll do sine of theta is equal to 1 on root 2. Unit circle time. So there's my unit circle, and once again, where is 1 on root 2? Well, Sine is to do with the y-axis, so we're drawing on the y-axis. And it's a positive value, so it's going to be on the positive y-axis. Half's about here. 1 on root 2, root 3 on 2. So we're interested in this one here. And here you can see that there are two solutions, one out here, one out here. So the first angle is this one here, the second angle is this one here. So when does 1 on root 2 appear? Well, it only appears in those 45-degree angle triangles or the pi on 4 triangles. So pi on 4, 2 pi on 4, 3 pi on 4, 4 pi on 4, 5 pi on 4, 6 pi on 4, 7 pi on 4 is out here. And then 8 pi on 4 takes us back to the start. So what are these two angles? Well, this one's 1/4, so pi on 4. And the blue angle is 3 pi on 4. Alrighty, so pi on 4, 3 pi on 4, and we are left with theta 1 equal to pi on 4, and theta 2 equal to 3 pi on 4. And there is a sine example. The hardest one to conceptually do is going to be tan. Tan is an interesting function, for it's mostly based on the values of x and y, meaning it's based on sine of theta over cosine of theta. And tan is going to be bigger when sine is bigger, and tan is going to be smaller when cos is bigger, right? Because when you divide by something big, you get something small. So we're always kind of trying to be interested in the relationship between sine and cosine values. Usually means what's going on. Let's try sine over cos is equal to 1 over root 3. Now that, and let's make it negative as well. Let's do a proper little tricky one here. So negative 1 over root 3. So we're looking for values in which cos and sine are not the same. And number 2, we're also looking for ones where cos is bigger than sine. Why? Because the denominator is bigger than the numerator. So that means cos must be bigger than sine. So let's draw a unit circle and see if we can find some places where cos is going to be bigger than sine. So let's eliminate some possibilities. The first one to eliminate would be the 45-degree angle. Why? Because, have a look, the x and the y coordinates are exactly the same size. They're both 1 on root 2. Therefore, it cannot be a 45-degree angle. Could it be a pi on 3? Well, here, the y-coordinate is bigger than the x-coordinate. Well, that's no good, because remember, the y-coordinate is sine, the x-coordinate is cos. So that's not going to work either. So we must be looking for an angle like pi on 6. But there's a reason pi on 6 doesn't work, right? It works in the sense that sine is bigger than cos, but the problem is that the value is negative, and we need to figure out which areas is this going to be negative. So let's have a look. This is the all stations to central. So where is tan going to be negative? Well, tan is going to be negative in the sine quadrant and the cosine quadrant, because it would be positive in the tan quadrant and the all quadrant. So it's going to be positive here and here. Oh, sorry, it's going to be negative here and here. So now what we need to do is redraw this angle, but in relation to these ones. So we could either draw this angle up here like this, or like this. But once again, remember, we've still got to keep that rule in mind, right? In this angle here, the y-coordinate is bigger than the x-coordinate, which is wrong. Whereas over here, the x-coordinate is bigger than the y-coordinate. So this angle would work just fine. That's our first solution. And our second solution is going to be the same issue over here. Right? Which one's going to work? Well, long, short. That's right. X long, Y short. This one doesn't work. Y long, Y short X. So these are our solutions. Now let's draw in all of our pi on 6th angles, and we will count them up. So for the first solution we had was this one over here. That is going to be 1, 2, 3, 4, 5. Theta 1 equals 5 pi on 6. The second angle is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi on 6. And there are our two solutions within 0 and 2 pi. Alrighty, so that's solving for the non-general solutions. Next time we'll be solving for the general solutions. See you in the next one. Bye-bye.